Silicon Valley Future Forum.
Thank you. It's an honor to be here. We are going to try to run this video from this clicker, talk a little bit about our company and some of the ways we're using artificial intelligence and machine learning. We spun out of the university about 17 years ago into my garage. We've bootstrapped probably about $100 million in funding through working with large manufacturers and large end users in the industrial field. This is our location. We're in Logan, Utah, up in northern Utah. And first application I'm going to talk about is agriculture. We spun out primarily with John Deere as an initial partner, and the goal was to automate orchard and vineyards to start with. And so the goal being get the humans out of the dangerous chemicals and provide them with a safe remote location where they can control these vehicles and do the farming. And as you can see from this video, we have some challenges with obstacle detection and avoidance. The lasers and the cameras cannot see through the dust and are completely blocked as the dust gets worse and worse. And so one of the challenges is using machine learning. How do we adapt the environment that we're detecting and change the sensors that we're using, change our confidence in the sensors, and actually change the math in determining where it's safe to drive and where it isn't, as we have challenges with fog and dust and rain and hail and snow. And so that is one way in which we're using the intelligence of the artificial intelligence to change as the weather we're experiencing, the environment that we're experiencing changes. We actually change our math and help us navigate safely. Another challenge in orchards and vineyards is that as you're driving, this is a vineyard in California, you have the difficulty of seeing through the branches. So as the vines grow in, you start to have blockage both optically and both by the lasers and the cameras that they can't see through the terrain. And so you have to use radar and physical bumpers to help manage that navigation. We've also used neural nets, trained neural nets, to help us understand what the equipment is supposed to be doing, because as you take the operators out of the chair, you now have to replicate their 5 senses. And instead of just trying to get from point A to point B, you actually need to operate the equipment and determine whether it's operating correctly and change that management of that equipment to make sure that you're optimizing whether it's a harvest or a tillage operation. And so we've had to use trained neural nets to understand what is the ideal operation of the implements and then view and determine whether the equipment is operating correctly and then change it if it isn't. One of the ways that we've used to determine whether equipment is actually functioning and not broken is an audio signal. So we've had to use intelligence to train what are the normal audio signals that we should be getting from this equipment and train that, and then as this equipment is operating, something might go wrong and they might start to wear out a bearing, or they might start to wear out the blades on a mower, and those will make different sounds that are not standard in what has been trained. We will trigger on that and then alert the operator that there is a maintenance issue. This is modern day, so these are some operations that we've been doing last year and this year. This is an example of a very large piece of equipment coming up to an obstacle. It's fusing sensors from the front of the vehicle that include radar, cameras, and LiDAR. In this farming operation, the farmer has chosen to make sure he validates all of the decisions because he doesn't want his seeder running off randomly to avoid a cow and not cover the field that he needs to plant. One of the exciting opportunities in agriculture is optimizing the operation with lots of different vehicles. And so we've used multi-agent simulation for swarm type theory to optimize the operation. We've actually helped the equipment manufacturers size their equipment correctly. So what size, how many bushels should that combine carry? What should the combine grain cart that's being pulled by that tractor, what is the optimal size for that? And so as we create simulations, we can optimize the size, we can optimize the flow of equipment. We can optimize what is the right number of equipment should you have for your size of farm. And then ultimately maximizing that flow of wheat or harvest, and make sure that you're maximizing the flow as fast as possible for the lowest cost. The farmer is then able to remotely manage the operation and through big data flow all of the information coming up from his different fields, and then start to get to the point where he can do predictive maintenance. So he can have, as the equipment is about to fail, that he can have the new oil filters sent out from the dealership so that he's ready to put those in. He can predict when his engine is going to fail, when his tractor is going to break down, and then proactively fix those vehicles and not have to have downtime in the field. So where we're at right now is we've finally gotten legal approval to place these in field trials this year, and so that is an exciting phase. Mining is the next application. We started this about 10 years ago, and the goal being to optimize the flow of gold out of a mine. And so this is an autonomous truck probably from 8 or 9 years ago. We now have autonomous truck operation running down in South Africa. It's been running for about 3 years. This year we'll be expanding that operation and then starting 2 new mines to run full autonomous. Some of the challenges in mining, they have the worst probably weather and environment to operate in. They are typically in some of the most remote areas in the world, on the top of a mountain in Peru, where you can have winds so fast that gravel can fly off of the road and break your windshield. And so you've got to be able to see through fog and rain and snow. And again, we need to dynamically change our math as we detect those kinds of inputs from the environment. I'm in fog. I need to take my dependence and lower my confidence in my laser and my camera systems and move more confidence towards the radars and slow my operation to be safe with that different kind of sensor portfolio. There's also a lot of opportunity for optimization in the mine site. You can see you have lots of different pieces of equipment. You have these pieces of equipment that are dealing with the earth. So they're digging through the environment. They're digging through rock that is changing in density, maybe copper, then rock, and then maybe a coal seam. And so that equipment needs to intelligently be able to determine what kind of material it's going through and then optimize the control of those blades as they move through the material. The optimization opportunities are huge. As you look at mining operations that are producing $1 million an hour, even per one piece of equipment, the ability to optimize the flow of that gold out of that mine, optimize every piece of equipment to make sure that it is doing its best job, and then predictively addressing maintenance issues so that as these equipment are getting closer to their failure modes, that proactive safety, proactive service can be done and avoid that downtime that can be millions of dollars per hour. The exciting place where we're going now is that as we collect data, we are going to use the big data analysis to determine what is the transfer function, what's the correlation between maintenance costs and productivity. So if I haul 4,000 ounces of gold per hour and my percentage in maintenance is 5%, if I haul more gold, meaning I drive faster, I accelerate quicker, I slow down faster, what is my cost of maintenance? And as you start to get that correlation, you can start to tune. So as the price of gold goes up, I may want to drive faster because I'm willing to take the increased maintenance costs. I know that I'll wear my tires out faster. I know I will consume more fuel, but because the gold price is up here, I take that pain and I'm willing to take that increased maintenance cost to get the productivity up. Whereas maybe fuel costs are coming up. Maybe the price of tires, we can get as high as $150,000 per tire, and gold prices are low. I might choose to preserve my tires, get better fuel consumption, slow down my vehicle on turns, slow down my accelerations and decelerations to optimize that for the different conditions. So as I bring all of that data in, I can start to look at the big data problem of I have inputs of fuel costs, of gold prices, of tire prices, of the other environmental impacts that I have, and I can optimize that over time and change how I drive, how aggressively do I produce the gold. So exciting opportunities there. This is an explosives truck that this is currently fielding down in South America, and so it's carrying explosives. So the goal is to get all of the equipment in the mine site to be full autonomous so that no one is in these environments so that they can be hurt. One of the biggest costs in mining is getting the dirt off of the top of the ore. So I want to get to the gold. If I can make my walls steeper on my open pit mines, I can then remove far less dirt to get down to the precious metals. And so the danger with that is that the walls can collapse and someone could get hurt. And so the goal is to get everyone out of the mine, run it remotely, and maximize the flow of material. Next application is in automotive. We automate the testing for most of the automotive manufacturers, and so in their proving grounds, we automate the testing for their durability. So they're trying to put thousands of miles on per month, and we provide autonomous packages that put these vehicles into an autonomous mode, and an operator at a command center can then manage these multiple vehicles working together. We have to handle very rough conditions. You can see here, this is Ford in Detroit. We have to make sure that the vehicles can drive safely no matter what kind of conditions they have to experience. So airbag testing, rollover testing, rough terrain, that autonomous vehicle needs to dynamically adjust to that poor road surface and drive autonomously. We're also exploring some autonomous bus work in China with some potential partners that manufacture the buses. The next application is autonomous cleaning. So this is floor scrubbing. We're partnered with one of the world's largest floor scrubbers to optimize floor scrubbing. One of the biggest challenges that we have to apply artificial intelligence to is the mapping of these environments. If you go to a grocery store or a hardware store like Home Depot or an airport, they change a lot. In grocery stores, they're constantly changing their layout. They're adding new features, new products that they want to sell on the ends. They're moving their shelves around. We need to dynamically learn that environment, position ourselves relative to that environment, and then continue to update that map as we go and learn from all the things that are changing and still do the operation. We also have to address some very difficult safety scenarios because we have very small rows where we're trying to drive and there are children all around the vehicles. And so how can we operate safely? How can we do it very affordably with very low-cost sensors and make sure that we don't hurt anyone? We also have to do classification. There are constantly things falling into the rows, and we need to make sure that we are cleaning things that need to be cleaned and not going over things that will damage the cleaner. And so we have to use deep learning to look at the types of things that are falling in front of the vehicle that have fallen off of the shelves. Perhaps it's someone that has fallen down. It could be a dangerous spill. Classifying those and then making the wise decision on whether to clean those or to alert maintenance for support. You can see this vehicle is learning the map as it's driving. Another fun application is security vehicles. And so this is for security surveillance. This is with Foxconn and Sharp. This product has just started to sell this month. And it looks like we'll have a couple hundred unit sales this year. One of the most challenging deep learning problems that we're trying to solve is that we are trying to classify things that don't want to be classified. So a bad guy is hiding underneath of a tree. He does not want to be classified as a bad guy. He wants to be classified as a rock. And so how do we use deep learning to correctly classify when there are threats, when there are people who are trying to take things to cause damage to a facility, steal something from a facility? How do we use intelligence to correctly classify when there's a threat and when isn't there, and then alert and address that problem? Again, there's a multi-vehicle optimization challenge as we look at how do we minimize the threats to a facility. We may have 5 robots. We need to dynamically determine where are the threats going to come from and then minimize those threats. And so as we distribute these vehicles around, as we look at the environmental situations. Oh, it's starting to rain. Where would a bad guy attack this facility if it's raining? And then be able to dynamically tell the robots where to go and create the safest coverage of the facility to avoid the threat. Material handling has been around for a long time. We call these AGVs, automatic guided vehicles. This is one that we did probably 12 years ago and have thousands of those in the field. Now we're starting to get requests to do more non-structured environments. And so we're working with one of the largest package handlers in the world to do package handling. So I've got a guitar and I need to get it to truck bay number 7, or I'm trying to build something and I need to have materials sent to me randomly. Creating a very non-structured, user-friendly package handling system that I can deploy and easily send things away and request things and have these things moving around with humans all over the environment. And so we have underway programs in that area. And then finally, this is what we call a chaos robot. We have about 3 different military programs right now with the Department of Defense for machine learning and artificial intelligence, and how can we apply those lessons to vehicle navigation, help vehicles drive more intelligently, detect the environment, and respond safely. This one's a fun one because you can start to use reinforcement learning to help this vehicle navigate more effectively through an environment. So you can change the gait, the walking of this robot, change the arm positions to help it progress through the environment as effectively as possible and detect those kinds of changes, whether you're moving through forest-type material from snow to water and boulders. So that's exciting. This is also being deployed in underground mining in Australia as we look at places that are very hard to get to, that are difficult for humans to be in, and where their safety is at risk. So that's in general what we have going on. We are very excited because we are finally at a point now where the cost of sensors, the cost of computation is matching with the demand. We are getting a ton of demand right now in the US. The Democrats are increasing the minimum wage and the Republicans are shutting down the border, and that is helping us in increasing this demand as people must have solutions that are more affordable to do the day-to-day operations that they're doing in their farms and factories. So that is what we are up to in leveraging artificial intelligence and machine learning and robots.
Silicon Valley Future Forum.